It has been a long time, but now it is time to begin the game dev stream. I hope that isn't too loud. Is my desktop audio? It is muted. Let's unmute that shit. Ooh, that's nice. Tonight we're listening to Jazzanova, Belle et Faux. I don't speak French, but this is some amazing, sexy, funky shit we're listening to tonight. And this is gonna guide us through the game dev, what we're doing tonight. And I think we're almost ready to begin. Let me just pimp the stream once more. Let's make sure everything's being recorded correctly. It looks like my voice is coming through. It looks like stream is up. I'm just gonna post it up on Facebook once more and Twitter, and then we're gonna get ready to go. All right. The message has been sent out. Assemble your crew. Yes, crew. Very important to assemble your crew. We got the Infinity Ward red water. Drinking that shit. Getting hydrated. Listening to the good stuff. Okay. And getting hyped for game dev tonight. I know it's been a while, and let's go. Let's start. Switch scenes. Whoosh. Hello, humans. This is Magenta the Kitten Eating Ghost Streamu, and tonight we're going to be implementing collision in my fluid simulation in Magenta the Kitten Eating Ghost. So I haven't been on stream for probably a month now. I don't know how long it's been. It's been a while. Let's say it's been a month at least. And in the meantime, I went on vacation. I had break from work, break from everything, break from the universe, and I implemented a fluid simulation that looks pretty hot. Sorry about that. A little cat hair in the mouth. Just the taste of a delicious cat. So, to show it off, this is the wrong thing to show off. Some things are effed up a little bit. I think the controls are kind of borked. I think the last thing that we did, we were trying to implement a new control scheme, and I got really frustrated because it was actually impossible to implement what I wanted to do in a event-based paradigm. I figured out the solution to that, but haven't implemented it. And we may get around to doing that sometime, but not tonight. You notice there's this little... Well, it's hard to indicate. I'm going to use my mouse. This thing up here, this sort of red texture, that's actually a voxelized version of the scene. Voxelized in 2D really just means rasterized. This is a rasterized version of the scene. Basically, it's a smaller... We render the scene again in a smaller texture, and we only output information about where we want the fluid to collide. Let's go over to the fluid test scene. We got... all right, there's some bad cats around here doing bad cat shit, and I'm going to spray the shit out of them if they do some bad stuff. You'll notice that my amazing green screen isn't fucked up except for a little bit over there. Over here. And that's because there's literally a cat right there. I can't spray it because it's wrapped up in the green screen. I can't even show it to you because it's invisible because of the chroma key. But if it does reveal itself, we're gonna get it. We're gonna get that piece of shit. Punishment. Okay. We're switching over to the fluid fluid scene. Yeah, let's save this. Okay, We got velocity, pressure, and divergence, my 3 favorite quantities. You may note that once we get into the simulation, these properties are these quantities are not the actual quantities being displayed. For instance, the leftmost quantity, it's hard to point. The leftmost quantity, it's actually, this one, the one labeled velocity is not velocity. Indeed, it is density. Density isn't even one of these options. I know. What would you think about that, huh? The center one here, not pressure either. This is actually the level of residual at the coarsest, the residual at the coarsest level of my multi-grid simulation, or multi-grid solver. So this isn't just your average everyday fluid simulation, although it is in some regards. But I did implement a fully recursive multi-grid solver, which makes this shit run at 1,000 FPS, right? This is fast, like, and it's like pretty HQ, right? These textures are 1024 by 1024, by the way. So, right. So this is we got density on the left. We got not divergence. Density on the left. Coarsest level residual in the center, and residual is just it is the Laplacian of the pressure. No, Laplacian of the divergence minus the pressure, something like that. I don't really know. I mean, I read a book on multi-grid solvers, and that's how I figured this out. So don't really worry about the middle one there too much. And then the rightmost one, that would be velocity, actually. Velocity in two colors, which means red is pointing to the right, and green is pointing to the up. So think it's a vector field, right? You know what a vector is? A vector is like an arrow. Think of it as an arrow. It's an arrow that has a length to it. So like you can have a long vector that's like this long. Ooh, that's a vector. That's absolutely a vector. Or you can have like a very short vector that's like that long, right? This is not a good explanation. Anyways, think of them as arrows with lengths to them. And that represents how fast a thing is going if put into the fluid. So imagine everything pointing right is red and everything pointing up is green. So what does that mean if it's yellow? What's red plus green? It's yellow. So that means it's pointing to the up and to the right. Well, that's hard to show because the camera's reversed. It's pointing to the up and right. The trouble with this is that everything pointing left and down is black because it's negative. You can't have negative colors. So as we add fluid and velocity, or add density and velocity to the simulation, you'll notice the changing colors. So like, watch, I'm going to add something pointing to the up and right in the upper left corner, and it turns yellow, right? That's cool, huh? We even got some settings here. We've got McCormick advection. We got viscosity, vorticity. Check out that shit. Now we got vorticity. Everything's looking crazy. It's vorticity confinement. We also added in viscosity. We can do McCormick advection, which is a second order approximation on advection instead of a first order one, which should make things look a little more, also sort of chaotic in the way things are advected, less smoothly advected. And then I have velocity advection here as well, which it doesn't really tend to do anything but make things faster. So I'm probably not gonna use that one. So let's turn that off. Right, and I don't even know if we're gonna use viscosity either. So this looks pretty sweet already. Like, dang, bro. You'll notice that it's actually kind of hard to get any sort of accuracy, like an accurate effect. Like if I want to, I'm holding all the way to the right in the simulation right now, and it's shooting kind of down. It's because there's actually like a vortex thing going on here. So a good thing to do is actually add a velocity fade, which makes the velocity decrease by a certain amount over time. It's like a dampening factor on the velocity, and now we can have like a much more controlled effect here. Also note that in the game, the scales are going to be much smaller. This is a 1024 by 1024 texture, but it's actually fairly small on screen. So an individual pixel here is smaller than the screen resolution. Which basically means you're missing some of the detail here because it's not per pixel accurate. It looks kind of cool. I'm sure that's actually killing the shit out of my stream. Maybe? I can't tell. It looks like it's all right. It's just kind of hard to compress high-frequency images like that. Anyways, so this is the fluid demo. What we're going to do is we're going to take this, we're going to put it into the game. This is actually the same game project. But we're going to put it into the game scene. We're going to voxelize. We're going to voxelize in 2 dimensions. We're going to rasterize the scene into the same domain as the simulation so that obstacles in the simulation, well, so the scene can be an obstacle in the simulation, basically. Does that make sense? So we've already done a little, I've already taken a little bit of the steps. I just like watching this. It's just really cool looking, right? Super cool looking. Look at that. Just imagine that being like a cloud of ghost sauce right there. Super hot. Cats, all right, punishment time. Punishment time. Huh? Yeah, that's right. That's right. Yeah, okay. Punishment time. Oh, those cats. Right. So, we're gonna take this. In fact, I think what I would like to do is just turn this into a prefab. We're gonna call this stop play mode. We're gonna call this fluid grid. Let's call it fluid grid. Let's make sure we take the space off the end of that. That's gonna be a nightmare if that actually happens. Grab that, drag it in there. Now we got a fluid grid prefab. It should be fairly self-contained. Huh? Huh? Yeah? 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 You see, there's a cat here. Oh my god, this cat. Punishment. So we're gonna take that. We made a prefab. We're gonna bring it into the game scene. We're gonna see what happens. We're gonna size it up. We're gonna do some alpha blending. And then we're gonna put the scene voxels or the scene geometry as obstacles in the simulation. And that's the plan. I want to make sure we don't need any of this stuff. I don't think we do. I think this is just debug crap. Yeah, pretty much. Okay. Let's go on over to the fluid. Nope. I think it's just called test. Don't save. Okay, here we are. We're back in the game. Blah, blah, tongue, blah, blah. Okay, cool. We don't got any fluids. We don't got any fluids. But we still got video games. We got farting and beams, just like last time. Oh, yeah. Just lick that. That's right. It's delicious. Cool. So let's drag on in our fluid sim. Cat, get out of here. I'm gonna spray you. Kitten, go. What? You sprayed me? Oh, liquid water, my weakness! Not only a weirdo, but a weirdingo. I think that is the correct appellation. Okay, let's put the fluid grid in here. See how slow things are. Not too slow. We're at 200 FPS. That's pretty good. Velocity debug of fluid grid has not been assigned. You know what? I bet the fluid sim wasn't even running. Let's take out those debugs. Let's take out the debugs. Yeah, this is like a couple hundred lines. What are we at? We're at line 400 here. We're in and for 400 lines of script and about 600 lines of shader. So 1,000 lines for this hot fluid simulation. Oh baby, oh baby. What we're gonna do here is we're just gonna get rid of these debug textures so that Unity stops complaining. There we go. Actually, performance increased. Cool. Okay, so we have to do a few things at least. We need to probably, let's actually have a, I'm conflicted. Let us have a density debug right here because we're stupid. Velocity debug. Make sure this still all works. Okay, cool. Things are running. We're going fast still. Nice. Nice. We actually want to shade this in a sort of specific way, right? We don't want it to be black. We want it to appear on screen transparent except where there's density. So basically, we're going to use the density field as sort of a fluid indication. But right now, whoa, shit. Don't do that. I clicked on the wrong screen. Cats, punishment time. I set up this green screen, and it's so perfect, and the cat's just like going nuts. They're like, man, I can't believe he put the green screen laying on the ground. I'm gonna cut, whatever. Kitties. Fluid. Okay. Right, so one thing we want to do is we want to fit this quad to the screen. I think that makes sense. Yeah, let's do that. Or just use this as the camera render texture? It's hard to say. I mean, for now we can. Hard to say, hard to say. I mean, we just, maybe a post effect? We could do it like a post effect. I mean, that is kind of what we want. I don't know how to do it as a post effect. We've got a couple things we can do here. I think the easiest thing to do right now is actually bring the voxels into the simulation. It's pretty easy. So we'll do that, and then we'll think about how to fit it to this camera, because that takes tuning and ideas about visualization and all sorts of stuff. All I have to do is grab this thing and they fly away. They're just gonna learn. They gotta learn. Okay. So instead, what we need to do, we have a function called isBoundary. IsBoundary. Where is that? There it is. That was easy. And instead of doing all this math, not even once, what we're going to want to do is, we have this little center thing here. I think we're going to want to keep this outer boundary thing We maybe do not want it all, like, we don't really want fluid to like stop at the edge. We just kind of want it to go away, right? But we'll leave it there for now because I'm not really sure how to handle that. So instead, what we're gonna do is we're gonna have a is fixed a thing, texture 2D, fixed, because it is a fixed point number, and we're gonna call this boundary texture, in boundary texture. And what we'll do is we will sample either or center or in boundary texture. Hey. So this is a compute shader, by the way. Cats. 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 Stop it. Stop it. Stop it. Stop it. Stop it. This boundary texture is going to be the voxelized scene, basically. I keep saying voxelized because I used to do this in 3D, right? And in 3D, you do actually have voxels, which are like volumetric pixels, right? Or volume elements, if you want to like think about what the etymology of the word actually is. And here, it's just the rasterized scene into an integer texture, kind of. We're only outputting like complete red for an occlude or a blocker, an obstacle. There you go. And yeah, we're gonna see if that's a syntax error or not. I kind of imagined it would be. So fixed isn't actually a word. How about int? It should come in as an int between 0 and 255. I hope. We'll see. Maybe we can do float. I bet it just needs to be float. Okay. Undeclared identifier. ID. Okay, we spelled something that's index. Might be. Hey! Compiled. Cool. So basically what we want to do is take that texture. Let's add a component to this. We're going to call it obstacle texture. Oiblik, public. We actually want to put this somewhere else because these are so necessary. Maybe these shouldn't even be public, right? Let's have a public render texture. Because these don't need to be accessed from anything else, right? They're just cluttering up our inspector and stuff like that. But we do want to assign our obstacle texture to a real thing. And right, let's actually, so this is stupid, kind of. So we have our voxel cam, which has obstacle voxelizer on it. It has a voxel texture. And what we want to do is grab the voxel texture and put it in the fluid sim. Now, if we do this on the beginning or on start, depending on what order things happen, we may or may not be able to actually do that. If the voxel camera starts after the fluid sim starts, then the texture won't be created and we'll have a null reference exception. So what we could do is we could initialize the fluid texture in obstacles code, but that seems totally bonkers. So instead, I'm just going to kind of adhere to this protocol that I've set up for myself, which is self-initialization happens in awake. And awake, all the awake calls happen before all the start calls. So is this all this shit allowed? Can we do this? I mean, we may not actually be able to do all this in Awake, but we're gonna try. So self-initialization happens in Awake. Is everything busted? No, things look like it's working still. We still have fluid. This is broken. I think that's because that texture is returning 0 always because it's unloaded, or we didn't actually assign it. So we need to do that before the fluid sim will work again. So instead, what we're gonna do is we're gonna add another field here. In fact, let's not do that. We're gonna get a public voxelizer. I'm gonna call this obstacles. Obstacle? In the beginning of each frame, we're just gonna set that. Oh. Interesting. Are these kernels? Or are these slots? Yeah, they're kernels. Okay. So, it would be nice if we could just sort of set a global texture. You can do that in regular HLSL. You just specify a texture slot. Not sure how it works here. What we may actually have to do is just set it on every texture, or just set it on one texture, or set it on the texture with the most things. We just want it to go in a slot that's like way down there and stay there. Well, we can just sort of set it on every single one. It won't be terrible. So let's just go down. So the first thing we're doing, that's here, do fluid compute.set texture, add vect kernel. We're gonna call this in boundary texture. That's how we called it. In boundary texture, that's right. And this is going to be obstacles dot voxel texture. There it is. Oops. Now I've run into situations where this isn't actually like strictly necessary. So what is this? I've got some reality slipping out at the top. That's very funny. I don't really know what that's about. Have to look into it some other time. So basically we're just gonna copy and paste this. A couple times. And rename things appropriately. Compute vel advection. You know, we could probably make that a function and it would be less annoying to copy and paste over and over, but that's ridiculous. I don't recall if viscous diffusion is required for this. Or if this is required for viscous diffusion, but might as well. Basically everything that calls that is in boundary function needs this texture. Sure, put it in the forces kernel as well. Forces kernel? Definitely in the divergence kernel. Definitely in the projection kernel. My fingers are getting tired. Probably needed in the vorticity kernel, but the vorticity kernel is not that important. The vorticity kernel is not that important. Take that, vorticity kernel. I have demoted you. Oops. Oops. Yes. Project vorticity. Perfect. Smooth. Certainly important. This may actually, like, pretty severely impact our performance. Because we are indeed reading a lot. Well, a lot. A lot from this texture. But hopefully not. It's just an R8. That's the smallest texture you can get as far as I know. Does the residual... I don't actually know if the residual kernel uses boundary. Well, it's definitely in relaxed error, but we don't call relaxed error. That's sort of legacy. That might be it. That might be all we need. Yep, okay. Well. Cats, I'm gonna get out of here. Okay. Maybe this will work. No, something bad happened. Object reference not set to instance of object. That is absolutely true. I did not assign the voxelizer here. Might be. Hey, look at that shit. Uh-huh. Hey. Is that amazing? That's pretty fucking amazing. I'm getting attacked by stuff. I'm dead. Let's move these down a bit so we can actually see them. Well, if you don't understand what you're actually seeing here, it's that this, the texture on the right represents the scene, the voxelized scene, and the texture on the left is the density. So you can see, imagine this, the left texture superimposed on top of the entire screen. It would indeed, let's actually just try it. Like, let's make this big. Oh, not like that. Let's make it big. Let's respect. So basically, I want to find the screen. We can do this. We can do it. We can do it. We can do it. We can grab the locations of the corner of the camera in world space and snap the fucking quad to it. It's like the dumbest way possible, but it's probably an okay test to just try it. To see if it looks all right and if the resolution is good. So we'll do that. We're gonna give this a public gam object. This will be fluid quad. And every frame, we're going to find the corners of our camera. So copy camera dot get screen point to ray, screen point to world point. Yes. Now, does this take viewport point to world to screen point? I want viewport point to world point. Can I have that? Let's make sure viewport is what we think it is. Transforms viewer space, screen space. Your space normalized and relative to the camera. The bottom left is 0, 0. The top right is 1, 1. That's exactly what we want. Defining pixels, the bottom left of the screen. Okay, so we'll find the pixel position, and then we'll pass that into the screen space to world space thing. So it's going to be a little stupid, but we're going to call this bottom left. This is going to be 0, 0, 0, 0. Well, I guess we have to do new vector 3. Well, whatever. 3 dimensions. That's the number of dimensions that we want. I spelled bottom wrong. Bottom left, and this is going to be top right. This is going to be 1, 1. Now, we may not want the z coordinate of our quad to be actually in front of everything because, like, remember, it's not transparent right now, so it will literally cover everything and we won't be able to see. We may be able to like fudge it so that it renders behind everything. We'll see. We'll see. Oh, and then we want bottom left equals copy camera dot screen point to world point. Okie doke. No. Excuse me. Okay, and these are world points now. So now what we want to do is assign the position of the quad and the size of the quad to be the difference. Well, we want the position to be the center of this thing. In fact, why am I even doing this math? So instead, we actually want to do center. And that would be this thing, 0.5, 0.5. I don't know, I smell smoke, but I might just be going insane. Maybe I don't smell smoke. I don't know. It was a flash of inspiration. Or what the shit? Flash of madness. Insight. Come on, guys. Come on. You can do better than this. Okay. Got our center position. What we want is the size to be... We can do top right divided by 2. That'll give us the size in world space. We'll see. Quad. Fluid quad dot transform dot position equals center, and fluid quad dot transform dot scale local scale equals top right divided by 2. This isn't gonna work. We need to do bottom, top right minus bottom left. Yeah, that would not have worked. We want this to be a floating point of division. I don't know if that's important, but I'm gonna put it in there anyways. Okay. Is this the fluid quad? Let's make sure we have this. Fluid quad! You may pronounce it quad, but I have the disease that requires me to mispronounce things. I know the correct pronunciation of some things. Not everything, but some things. But I am required to mispronounce them. So it's going to be quad tonight. Oh, right, that was in the voxel cam. Let's assign our fluid quad. Okay, let's see if it works at all. Where's fluid quad? The scale is 0. That's unusual. Transform is indeed. Did I die? I died. Okay. Why is the scale 0? It's not divided by 2? See, I think 0 divided by 2 is still going to be 0. Am I making some mistake here? It doesn't look like I'm making any mistakes. What if I get rid of the subtraction? Oh. Sorry, there's something in my eye. That's rather unpleasant. Okay. Hard to say. Well, it's certainly increasing in size. Oh, it's because the distance is 0, isn't it? Which means that the world space distance is going to be 0. So we really want it to be at, I don't know. I guess we'll pick some depth. Oh. Let's try this again. How about that? At the depth of 1. And maybe it makes sense to be at the near plane distance. Well. Close that. Why doesn't my fluid quad render? Is it backwards? Fluid quad. You can do it. Well, it does actually look like simulation is occurring. Does it not? What's... It's very hard to actually tell what's going on. You can't see your character. Holy crap. Wow, that's incredibly unintuitive. I didn't even pick up the beam kitten. Punishment! Punishment. Okay. Why is not my quad viewable? What if we turn... that thing off? Turn that off. Very interesting. Why you no simulate? We could change this, yes. Well, guides backface culling is on. So let's turn that thing off again, because apparently ruined my shit. I'll go back to the script do. And we're gonna comment this shit out. Goodbye. Why does moving that quad cause my thing to stop working? Highly unusual. Oh. It's very big now. Yeah, no, it works though. What position is it at? Fluid quad. Was it because we didn't have any Z? This is very strange. Get out of here, get out of here, get out of here. Okay. Alright, that's cool. Oh. Could it be that... I don't know. There's no Z-scale? It's very big. Very, very big. Well, look at that. Stairs. Kinda works. Kind of. There's an optimization to be had here, which is that we should not simulate voxels that are fully, or we should not simulate fully encompassed obstacle voxels. We can actually probably make that. Make that optimization pretty quickly. I don't know if we should do it right now, though. Indeed, the most costly... Well, I don't actually know what the most costly part of the algorithm is anymore, now that we're just basically, like, our solver is so fast. I mean, we're still doing 10 iterations for fun, basically. We can probably get it down, though. That was the issue, that the Z-scale was 0, so why don't we change that shit. And how about we like make this 10? Float. Oof. Unity. Unity, why? Fluid grid dot transform dot look, this is so stupid. Fluid quad dot transform dot local scale var scale equals this. sc dot z equals 1, and then fluid grid dot transform equals. Oh, can't do that. Nope, can't set individual components. We gotta do this idiom every time. One of the most annoying things about Unity, and I wish we could do anything to fix it. Okay, cool. Cool. Look at that. Okay, we've got fluids, and it roughly corresponds to the world. Look at that. We should turn up the damping. Let's look at the frame rate. Cool. Yeah, nice, nice. Yeah. Okay, yeah. Let's add some velocity damping. Let's actually reduce this and see how the frame rate improves. It barely improves, which means we're not actually bound on memory. Well, we gain about 100 FPS, but at 500 FPS, that doesn't really matter, does it? So what I am going to add is some velocity fade here. This is a lot of velocity fade, and we're going to add less velocity fade than that. Cool. I think that I'm going to make that adjustable, this Z depth here, for that. So we can just adjust it so that it's fit to the screen. It might just be the near plane distance is what we want. Let's guess what the near plane distance is. It's 0.3. So if we set it to 0.3, then it's the near plane distance. Or if we set it to the 0.3 and it's the full screen size, then it's the near plane distance. If it's something else, then fuck if I know, really. And this might be wrong. Public float distance, Z depth. Let's call it Z depth. We're gonna stick it in here. Oops. Oh, yes. What is the definition of 10? Please tell me, Visual Studio. Where is 10 defined? I've always wondered. It's because I don't understand basic mathematics. Okay, Z depth. 0.3. Well, would you look at that? We can secretly break the simulation somehow. Very interesting. Let's try that again. Cats, I'm gonna throw you in the garbage. My mouse. Okay, something weird is going on with the way I'm calculating mouse coordinates now, but look at that. Look at that. That's great. We're getting a little bit of weirdness at that edge there. And let's go full screen with this. Maximize on play. And let's add those dampening things. Let's just turn that up to 99. Okay. I'll turn this off. Why is Dead hiding down there? I don't know. This is interesting. I'm not really sure what the deal is. So look at that. We can absolutely see the environment now just by fluiding onto it. This is really, really cool, guys. Really, really cool. Holy crap. I am very confused about so we do see some weird artifacting there. Do you see that? that, well, let me, the thing over here that's going on? I'm not really sure why that's happening. And it feels like, I mean, I'm thinking it probably shouldn't do that. But it might just be an effect of our velocities and sizes, right? What if we turn up the solver iterations? I mean, we are already doing a lot of solver iterations, so we might not want to do that. Is there a way to go back to scene view? Yeah, there is. So what if we change fluid quad? So yeah, I think this is just some weirdness with the way screen points are calculated when something is at the near plane. I don't know. I don't know. If we're not paused anymore, let's unmaximize. If we change this again, this doesn't actually matter, does it? No, it doesn't. Well, now these things actually work, and we're in the background. Okay. I like that, actually. This looks pretty sick. So yeah, let's turn up the solver iterations. I mean, 100 is way, way, way more than is necessary, but... Okay, so that issue is not dependent on solver iterations. It has some issue with how we're handling boundary conditions. So let's turn those back down. And we don't have translation in yet, so we definitely need to add in some support for translation of the grid. There's a paper on that, so don't worry, it's possible. This is super cool, guys. Super flippin' cool. Man, what a video game. All right, let's go up there. Look at this. We made a little fluid hole. Fluid hole. I know what you guys like. You guys like the fluid hole. I'm listening to some hot shit right now. This is my favorite song on this album. You can't tell what it is, but it's actually the Belifaux theme from, I don't know what Belifaux is, but cool. Let's add in, let's do the vorticity, viscosity, and amount of convection, and we'll have some funky fluids. Look at that spooky shit. Look at this gloom. I'm spooked. Yeah, this is going on YouTube. I mean, it's all going on YouTube, but particularly this bit. I'm gonna listen to that track again. We're going back. Yeah. Puts me in the zone. I do see some pretty weird artifacting. I can't tell if it's just because Well, let's turn off vorticity and see if it's still there. Yeah, it's due to vorticity. That's fine. Like I said, the ghost fluid here, let's go back to full screen there. So now this is actually pixel size. The simulation domain should be about the size of the pixels on the screen. It's at 1024 by 1024, and the height of the screen is 1080, so it's actually a little bit smaller than pixel size. So this aspect ratio business, well, we need to do something about the fact that it doesn't, reach to the edge of the screen. So we can maybe double the width of the simulation domain, though that will probably cut performance in half. I'm curious why my FPS went down so much. Okay. We go to 200 FPS when we're at full screen. Now if I turn off the fluid sim and go to full screen, how many FPSs are we at? Okay. That's very interesting. So when we do full screen sim, I guess it's just pushing more pixels, so it's fighting for more stuff. I don't really know. Have to guess. Let's turn the fluid grid back on there. Oh, well. Now we're at 400 FPS here. 200 FPS over here. The simulation seems to be busted. I will allow it. We do want this depth to be at 10, because that seemed nice. Get fluided upon. Get fluid upon. Yeah, that's right. Did I notice those artifacts when I was doing Mac advection? Let's make sure we're still getting those artifacts if we're doing Mac advection. Because if Mac advection solves it, then we don't gotta worry about it. I'm still probably handling boundary conditions incorrectly because I don't understand boundary conditions. I read one book. I took differential equations in freshman year of college. It's been a while. I remember we did talk about boundary conditions. That's like if you have a system of equations and you want to solve X number of unknowns, you have boundary conditions so that it's actually solvable, right? That's all I really understand about it. The boundary conditions make it so you have less than X number of equations and unknowns. So it basically makes it so that you don't have an under-constrained system. Is that right? Yeah. Hopefully, no one who knows anything is watching my stream. I can guarantee that because I am indeed the only person watching my stream right now. Whew. Is this clock right? Let's make sure this clock is right. Is it right? My phone is in the other room. The clock on my computer is just wrong. You can't even see it. My face is in the way. I can go to Google and be like, "Hey Google, what time is it?" What time is it? It is indeed 11:30. Okay, we haven't been going that long actually. I thought it might be later. What was I testing? I was testing Mac advection. Or whether Mac advection solved that weird artifacting. It does not. It maybe, let's get this fucking overlay out of here. Doesn't have any effect. It's hard to say. This is super cool though. Super duper flippin' cool. Indeed. Well, we weren't taking boundary conditions into every single step of the simulation, and we're probably not accounting for boundary conditions correctly in every single step of the simulation either. Like, how do I take boundary conditions into account for the residual projection phase? And stuff like that. Like, I don't know. Dog. That might be the result of... I mean, well, we can turn off the multi-grid solver. We can't turn off the multi-grid solver, but we can basically turn it into Jacobi iteration. Pure Jacobi iteration. In all of its slowness. Using... Actually, we have a runtime switch for that. Multi-grid levels of 0, which just does smoothing. So, look how crappy that looks. Well, it barely does anything. I think we need more iterations, that's why. So let's amp up the iterations, baby. Let's go to 1,000 iterations. All right, we are at 13 FPS. And it looks like garbage and is also really slow. And would you look at that, we still got artifacts. So, it is not, well, it is at least not purely an effect of the multi-grid. And the fact that we don't account for boundaries in all steps of the multi-grid sim. We should add in some gravity. That would be cool. What a sad little Jacobi iteration. Hey, we did it, guys. We added, well, we sort of got the thing in the thing. Ah, that feels great. And it looks fucking cool. I think after I'm done with this video, I'm gonna just do a little recording of the thing and post it up on Reddit and see what people like. Of course, the next steps are things like voxelizing emitters. That shouldn't be, I mean, what we'll end up doing is using a special shader for emitters and obstacles. It's separate. Right now, let me show you my voxelized shader. Outputs for, outputs 1. And if you noticed, in our compute shader is boundary. Just checks if it has value, and I guess this means if it's greater, if it's not 0, it's true. That's the C++ way, at least. So, yeah, that's it. I guess we can do like another thing, have like is emitter. And then only actually emitters need to be done at one step, so doing emission is a lot cheaper than doing arbitrary boundaries. There's also other kinds of boundaries, like there's a free slip boundary and a no slip boundary. I believe the free slip boundary is like 2 fluids, and the no slip boundary is like a solid obstacle. I might be wrong about that. I might have that backwards. There's really only 2 options. Yeah. So yeah, we can use this shader, the voxelized shader, to also draw emitters into the scene. So we don't have to use the mouse to like shoot fluid into the texture. Even though that's kind of cool and fun, the game isn't gonna use a mouse when we... Actually, I got a Steam controller. This isn't a Steam controller, but I got a Steam controller, and I'm gonna see if a Steam controller will solve my controller woes, my woes of being able to twin stick, movement, aiming, and also jumping, right? Because usually that's not a thing you can do, is aim and jump at the same time. But because you've got buttons on the aiming pad, you can do that. And the music's done just in time for the stream to be over. What else do we need to do? We need to... Oh, yes. Translate. I'll read the paper on the translation thing and figure that out. And voxelize emitters. And I want to couple this with sound simulation, which I have done previously. Now, I believe the pressure field can be used in both. Like, we'll just have the pressure field as a separate thing that is visualized, and likely we'll take the gradient. Is the gradient of a scalar field a vector field? Let's look that up. Google. Is the gradient of a scalar field a vector field? Question mark. Gradient of a scalar field. Yeah. We'll take the gradient of the pressure field, and that'll give us normals. And we'll use that for refraction. And that will be what? That'll be what we'll use to render sound into the game, right? We can have them interact even. We can have sound and pressure interact. I don't know if we're gonna couple them completely. I think what we'll do is we'll probably have a sound simulation and we'll put that into the fluid simulation, but not the other way around. Yeah, so we'll just add the fluid, or we'll add the sound simulation on top of the pressure field that the fluid sim does. But we don't really care about the sounds a fluid generates, right? We don't really care about the pressure field created by, or maybe we do. Maybe that would be super cool to visualize both. We might, why not? You know, if we've got both. Now, the wave equation, I think, is like partially encompassed in the way that an incompressible fluid works. Like, I've seen, like, when I just look at the pressure field, I see waves propagate around and do wavy stuff. So it may just be something we got for free, right? Out of the fluid simulation. I just don't know really how to, like, isolate that because because I don't really understand the mathematics 100%. I mean, I could tell you, this is the advection part of the equation, and this is the diffusion part, and this is the velocity. Well, advection and velocity are the same. Parts of the equation. But I can't tell you, this is the part that's responsible for the sound pressure waves bouncing around. So maybe I can talk to someone who's like way smarter than me, and they can figure it out, or tell me. Or I can just do a sound simulation separately. Okay. That was good. It was a good time. We had a good thing today. Let's check this shit in. Let's go to... I thought I put GitHub on my GitHub. Nope. Oh my god. GitHub. There it is. I thought I pinned it to my taskbar, but apparently not. Apparently I'm not good. Pin that to taskbar. I don't know why it's called GitHub-1. That's confusing. Maybe I have like more than one GitHub installed. We voxelized. Let's put it in scare quotes. Voxelized. Let's do like little wiggles too. The scene and put it into the fluid. No, I don't want to put this in my computer history. Let's just do that. Hot. Sync it. I know you guys are dying to see my history. Look, I have committed some things. I've been working on this for longer than 3 months. Maybe that's just how old my repo is, but nice. Okay, well, thanks for sticking around. That was one segment. We went for like 2 hours, right? Or maybe an hour and a half. I don't know, but we did some good stuff. So maybe I'll see you tomorrow. I'm gonna be playing The Witness tomorrow. I don't know if I'm gonna stream The Witness because I really want to enjoy it. It's not one of those games where like you can stream it and I mean I haven't played it, so maybe it is, but I highly doubt it. It's not a game that like you stream and you're just gonna. I don't really like streaming narrative-based games, even though it's not really a narrative-based game. It's like a linear experience, and you only get to have that experience one time. And sure, maybe if I was a famous or YouTube famous, internet famous dude who I got 1,000 views when I streamed a thing and it gave me money and subscribers and shit, and like, sure, that's my job. You're paying me for entertainment to play a game and entertain you. It's not for me, it's for you. But because nobody watches this shit anyways, I'm not gonna want to ruin my individual experience for no reason, basically. And like the reason that it would be ruined is because I'm streaming it, worrying about what I'm saying, trying to be entertaining. I hope that makes sense. I hope that sounds reasonable. If in like 1,000 years someone sees this and is like, you're unreasonable, you used to be cool. Sorry, I guess. Maybe Witness isn't that good. Maybe, if it's a big deal to you, say something and I might reconsider. Okay. That's it. See you later.